This should take 1.5 hours. Let's just see how far we get. Go. Complete table 1, positive of positive pion and the proton. What's the configuration of a pion? A pion is K1 is the one with strange particles. That means that this one is up, anti-down. Proton has relative charge +1 baryon number. This one is 0. I'm pretty sure. And this one is +1 and quark composition, up, anti-down, and up, down. I would also like to claim that we haven't done most of this. When a positive pion interacts with a proton, a kaon can be produced along with another strange particle. This is shown in this equation. Circle the type of interaction. Well, that's a pion and that's a kaon. That means weak nuclear or strong nuclear. Well, another strange particle interacts with a proton, strong nuclear. But that's 2 to 2. Deduce relative charge baryon number and strangeness of particle X. Well, if we go with charge, well, we've seen it up here. This is +2. So we know that kaon, K plus equals, what is a K plus? A K plus is up, anti-strange, I'm pretty sure. So that means that that one has 1, so that means it has to be +1. Baryon equals 0, and that one is 0. What would it be? Well, that one is a third, minus a third, that's 0 and 0 and 0. And now with the baryon number, that has a proton as well, so that's 1 and that's 0, so it has to be +1. And strangeness, well, that one is +1, so it has to be -1 because we know it's strong nuclear. Particle X can decay and produce a neutron and a positive pion. State the type of interaction here, weak. Explain your answer, quark type changes. Change in strangeness value can only happen in weak. A neutron and positive pion will then decay. The positive pion can decay into a positron, neutron, neutrino. Write down the equation for the decay of the neutron, where the neutron will decay into a proton plus an electron plus a antineutrino. Explain why no further decays occur. Proton equals most stable hadron. Proton is the most stable hadron. Photoelectric cell, no. Can be demonstrated with illuminating negatively charged plates. There are certain metals of ultraviolet light showing that the plate loses its charge. Explain why when the ultraviolet light is shone on positively charged plate, no charge is lost by the plate. Because in was a positively charged and ultraviolet, because in the photoelectric effect, the whole point is to eject negatively charged electrons, which can't be done if you would have a positive plate, as it wouldn't like make it equal, etc. Threshold frequency and work function are important in studying photoelectric effect. Summarize the work function of these metals. What's the formula? Is the formula not HF equals work function plus kinetic energy, maybe, I hope, plus kinetic energy. Work function in electron volts is that, and that. Okay. Discuss the combination of metal and UV light that could be. Describe the combinations of metal and UV light that could be used to demonstrate the idea of threshold frequency and the idea of work function. The hell? The hell? I have no clue. But it's a 6-mark question. Oh, Jesus. Jesus Christ. Are there anything on wave? Wait, are there actually nothing on waves? Oh no. Is this on waves? Tube stars, minimum distance, frequency. Well, this may or may not be waves. Yes. Well, I can do that. Well, I might be able to do this. Calculate the maximum kinetic energy in joules of the electrons emitted from the zinc plate when illuminated. Well, I've already done this. Well, I've already said that equals work function times, is it plus kinetic energy? So H times F. I need a calculator for this one. Let me get it out. So that is 1.2 times 10 to the 15 times 6.63 times 10 to the minus 34. 7.956 times 10 to the minus 19 equals, and then the work function is in electron volts, so that means that we would need to change it into normal electrons. So 1.2 times 10 to the 15 divided by 1.6 times 10 to the minus 19. That one would, is it divided by or times by? Well, I know that 1 joule is that, so that means that theoretically being it would be, it's that minus that. Another work function is 4.3 electron volts. 4.3 divided by 6 times 10 to the minus 19 times by 10 to the minus 19 minus 6.9 times 10 to the minus 19, which is about 1 times 10 to the minus 19. So why is your answer a maximum? Because why is your answer a maximum? Work function is minimum. Don't know what more you want from me there, Chief. Quickening tube used to demonstrate interference in a sound wave. Loudspeaker X produces a sound wave at one frequency. The sound wave enters the tube at the sound energy is divided equally before travelling along the fixed movable tubes. The sound waves superpose and detected by microphone at Y. The movable tube is adjusted so D2 equals D1. The waves travel at the same distance from X to Y and is shown as the movable tube is slowly pulled out. It is shown that it gets quieter and louder. Explain the variation in loudness. Well, goes past maxima and minima. Well, if they superimpose, that means that there would be a, well, there's obviously interference. If first loud equals constructive interference, as it would be moved out, this would go through to destructive interference, as the path difference between the two would move by a half n wavelength. Tube starts a position there. Calculate the minimum distance moved by the movable tube to detect at Y to be at its quietest. Frequency is that, speed of sound in air is that. Well, it's an open tube, that means that it looks kind of like that, which does a, oh, for God's sake, does a that, does a that. So that means the middle would be the quietest. So the frequency is that and the speed of end sound is that. Calculate the minimum distance moved. Does it give you a distance? No, it does not. Minimum distance moved by the movable tube for the sound to detect at that and at that. So where is it? Halfway at the wavelength. So calculate the wavelength divided by 2, I'm assuming. So 340, yeah, 340 over 800. So lambda equals 0.425, and then divided by 2, because it's a closed tube, equals 0.2125. Quink's tube can be used to determine the speed of sound. Instead, to explain the measurements you would be able to take to obtain a reliable value for the speed of sound, including Quink's tube of a sort of known frequency. Okay then. Wow, what I would actually do is first I'd work out like the maximum, and then I'd work out the minimum. Max, then distance to minimum equals half wavelength. No, it doesn't. Equals a quarter of a wavelength. Times the answer by 4 equals 1 wavelength. Times frequency equals speed. That's the best I got here. Now this is the one I can't do. Calculate the density of steel. So density equals mass over volume, I think. So diameter of a ball is that, mass is that, and height dropped is that. So the volume is density equals mass over volume. Calculate the density. Well, mass over volume. The mass is 16 grams. So 16 grams in kilograms is divided by 1,000. So 0.016 over, and then volume. So density is grams over volume, and that one's in millimeters. So to convert that into meters, that is 16 over 1,000. Oh wait, the mass is 16 grams. It's 16 over 1,000 equals 16 divided by 1,000. 0.016. So then formula 4 over 3 pi times answer. Wait, what's a formula for a volume? Answer cubed, maybe? Formula for the volume of sphere. 4 over 3 pi times radius cubed. So diameter is 8, so that is 8 divided by 1,000, so that is 2.14466 times 10 to the minus 16. So that's 0.016 over answer. So about 7.5 times 10 to the 123. And a testable bounces back to a height of that. Calculate the speed just before the impact. Well, speed equals distance times, no, but I have definitely F that. Wait, why am I even using this then? I have mass, diameter, volume, density. Why am I doing that? Well, what I should be doing is bounce back to that, calculate the speed before the impact. Well, speed equals distance over time, and it didn't give you a time, but I did give you a distance. Well, we know the distances, and we know the acceleration is 9.8. So is that final velocity equals initial velocity plus 2 times acceleration times distance. So v squared equals u squared plus 2 times acceleration, which is 9.81 times the distance 1.27. Oh yeah, it is in meters, so that is 24.9174. And now, do we have the initial velocity? The initial velocity is 1.97. The initial velocity is just before impact, so just before this is 0. So 0 squared equals x squared plus answer equals, my calculator is going to do it, cannot solve. 0 equals that plus 24.9174. Come on, don't tell me you can't solve that like you're chatting garbage. Okay. Just root that. Just like, let's just try that. 24.9174. I know the answer is going to round to 5, so I don't know why I'm doing this. Yeah, 5. Don't know why I spent all that time doing that. Calculate speed just after the impact. Well, we know that just before it was that, so we can just use the equation. So 5 squared plus, well, calculate speed just after the impact. Well, the speed just before the impact is 5, and it changed to 0, so that means that it goes from 0 up again. And momentum has to be conserved, but I don't have a formula for momentum, so I can't do that. Calculate the change in momentum. No clue. Time of contact was 40 milliseconds. Calculate the average force of the ball. What's force? Once again, didn't do momentum. Combined science. And we haven't learned this yet. Calculate with reference to momentum why the test should specify the material or the plinth that the lens sits on. Because more dense or more something material, more momentum can be decreased or increased based on plinth used, so would not be reproducible. Oh, we're nearly there. We have we have 3 minutes left. I get myself 20 minutes for this. Resistance temperatures that resistant thermistor makes up a potential divider. What is meant by potential divider? A divider which only lets in one way. I don't know, but we do it. Stereo explains what happens when voltmeter reading when the resistance of R is increased when the temperature is kept constant. When resistance is increased, V equals IR, the potential difference would overall increase. Or would it decrease? Potential difference would decrease. So explains what happens to the ammeter reading as the temperature of the thermistor increases. Would lower resistance, so higher current. Battery has that many volts, the temperature of 0 degrees, of resistance is that many ohms. Voltmeter is replaced by an alarm which sounds when a volt exceeds 3. Calculate the resistance of R which would cause. Calculate the resistance R that would cause the alarm to sound when the temperature is lowered to 0. No clue. Jesus. Step 1 that is made by a circuit instead of coming on temperature. Right. It comes on. Well, change the boundary, so would use a thermistor. Quick. Calculate. Oh, for God's sake. Well, there's no way of me doing it. I still have half an hour. Might as well finish this one. Explain why the engineer does not use the highest observed temperature at the location of the railway to design. Because that will not always be the case. Could have been anomalous in this case. Done. Okay. Mark scheme. I actually have the site up this time because I see we had to wait for everything to load. Okay. So, well, considering it's the start of year whatever, I don't think that was pretty bad. For 20 minutes as well. I think I low-key banged it. Okay then. Green pen the ting. 100 up anti-down UUD, yep. Strong nuclear circle, yep. 1 1 minus 1, yep. Weak nuclear, yep. Explain your answer. Strangers -1, strangers above the pion, and neutron above 0. Strangeness can change from 0, can only occur in weak interaction. Strangeness value can only happen in weak, yep. Neutron equals proton plus electron plus antineutrino, yep. And then this one, only particles that are meant are electron and positrons, and neutron and antineutrons are stable, and proton, which is the only stable baryon. Well, that's one I just didn't mention. The other one I didn't think would be important. 1.72. Well then, positively charged plate using follow and demonstrate likely. Oh, that's meant to be a 6 mark here, but it's not here. Oh, where's 2.1? Okay, the process involves the ejection of electrons which are negatively charged. Oh, I did mention that. And as electrons are ejected, would only make the positive charge greater. No. I think 1. Yeah, I sacked this one off, but do I get a mark for the equation? Yes. Yeah. Yes, I do. I get 1 for the equation. Next one is 1. Yep, 1 times 10 to the minus 19. Yep. And explain why it's the work function is a minimum. Yep. Next one. Initially, path difference is 0, so the wave and phase, the displacement is the maximum. So constructive interference. Did mention that. Where did I mention that? Destructive interference occurs when path difference is opposite. Yep. Initially, path sound is loud and then becomes quieter. I did actually mention that. Maximum, minimum. Next one. 3.2 is apparently half a wavelength is 0.21. So I got the first two and then just sacked it off. Got the first two, then just sacked it off for some reason. Start with D1 equals D2. Measure the distance moved from each successive maximum minima. Each is equal to a quarter of the wavelength. I've actually done that. I've just done that. I have written that, but very simply. Okay, 7.5, 7.4. You could have rounded. Speed, I put 5. What does this put? 5. Well, it puts 5.0, but okay. Yep, sacked it off. Impact time not stiff. Increased impact time would reduce the force of the impact. Alternative, softer plaintiff would decrease the change in momentum. I did write that, but I only wrote 1. Okay, next. At high temperatures, resistance is 5.1. Combination of resistors and series connected across a voltage source. No. You can tell this is what I just started going through a lot quicker. So 5.2. Increase PD across increases and voltmeter decrease resistance increase. Oh, I didn't get 3, I got 2. I only mentioned 2 points, so I couldn't have got 3. This one. High temperature resistance is lower. Higher current. And this was the point where I started just rushing. Collect an alarm across R, then across T. Nope, I talked about that, mister. And well, we sacked all of those off. Young's modulus is what you're meant to use. And the bell isn't always under stress or spends less time at the highest temperature. I did talk about that because it will not always spend on the highest temperature. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 30, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Well, guess that's happened again. That's like 60 exactly. So that was easy, Pete. Well, it wasn't exactly easy, but I'll try something better.